Hello all, welcome to the video. This video is the continuation of the previous video. This video will be discussing about the working of a CNN in simple terms. We'll be talking about the important terminologies of a CNN, namely filters, weights, pooling and layers. So look into the picture. I have a picture of a dog. So the dog picture, the image is represented as a matrix. The matrix is in turn converted into patterns. So how it is converted into patterns? By means of something called as filters. The output of a filter will be feature maps and the patterns convey meaning. So in other words, the patterns are converted into meaning or the semantics. So this is a very simple example of how an image is represented as a matrix. We have discussed in the previous video. I strongly advise you to look into the previous video and then it is advised to look into this video. Again, comparing traditional methods and CNNs, the traditional models like your artificial neural networks or the machine learning models completely ignore the structure of the network. Too many weights, maybe millions or billions of parameters, and no spatial awareness. Whereas if you take CNNs, they are very important. They preserve structure. They analyze the image with the help of filters, weight sharing mechanisms enabled, and they completely understand the vision. Getting into the topic, CNN does not see object as objects. It sees patterns in them. It builds objects from patterns. Very important. You take the example of a cat, the picture of a cat. A single pixel in the image is just a number. 2 pixels, 3 pixels or 4 pixels together, still it's just a number and it is meaningless. Patterns emerge only when pixels are grouped. So the vision begins when pixels meet their neighbors. So this is very important and CNN exactly does this. So CNN looks at the image as small patches, small regions like a 3x3 patch or a 5x5 patch or a 7x7 patch, one patch at a time. If you cannot understand, imagine like you are reading a book word by word, not all pages at once. So this is what CNN does to the image. It looks at the image one patch or a small region at a time. Let it be a 3x3 patch. This concept is called as local connectivity. And the next new terminology is filters. So filters act as pattern detectors. So we need to identify the pattern, right? So let it be a vertical edge detector, a corner detector, or a horizontal edge detector. These filters will slide over the image, simply sliding over the image, and performs the dot product operation, the traditional dot product operation. And the output of this will be a feature map, set of feature maps. Each filter again learns one question. Is my pattern present here or is my pattern not present here? If my pattern is present here, then the meaning is rendered. So, coming to the second most important terminology, layers. So let me just call as the first, second, third and the deeper layer. So you should imagine as set of series of layers. The CNN possesses set of series of layers, and the first convolution layer learns the edges and the lines of an image. Second convolution layer learns the corners and the curves of the image. The third convolution layer learns the parts of the image. If your image is a car or if your image is a face of a person, then the third convolution layer would have learned the wheels of the car and the eyes of the person. The deeper convolution layer will finally learn the object, that this is the face of a person or this is the picture of a car. So CNN builds understanding layer by layer, like playing your Lego blocks. Excellent example of CNN. The next terminology that I want to tell you is weight sharing mechanism, the genius mechanism of CNN. CNN uses the same filter everywhere. The pattern is recognized regardless of the position. So there will be a left eye and a right eye in the face of a man or a woman. The picture of a face has a left eye and a right eye. The same filter detects it. Magic. CNN doesn't care where the pattern is. The CNN is only bothered that it exists. The next important terminology that you want to know is called the pooling mechanism. Pooling mechanism is simply keeping what matters, what bothers. So pooling results in downsampling and retaining the strongest signals. So we don't remember all the details of the scene. So we remember only what stands out in our mind, right? So pooling exactly does the same. To list out the benefits of pooling will reduce the size, will reduce the noise, and might be it improves the robustness. So again, filter learns to ask the question again and again, is my pattern present here? If it is present, then the pattern is converted to meaning. Why exactly CNN is working? Because CNN preserves spatial structure, very important, learns features automatically, fewer number of parameters than ML models, hierarchical understanding is there, and it mimics human visual system. So CNN works because it respects how images are structured. But if you could look CNN globally, the global understanding, we need to understand the attention and the transformers also. But let us understand the basic working principle of CNN. The next video, I'll be talking about an example of CNN from scratch, and the more of filters, weights, and pooling mechanisms in detail. Stay connected. Happy learning. Thank you so much.